In this video, we are going to be discussing the textbook questions for organic chemistry, some basic principles and techniques. So the first question, what are the hybridization states of each carbon atom in the following compound? So we need to write down the hybridization state in each of the carbon atoms for the compounds, and this was discussed in the beginning of this chapter. So first of all, when a carbon has a triple bond, it is sp hybridized. When it has a double bond, it is sp2 hybridized, and when it has like 4 single bonds, then it is sp3 hybridized. So the first compound CH2, this carbon has a double bond, so it is sp2 hybridized, whereas this carbon has 2 double bonds, and because of the fact that it has 2 double bonds, it is sp hybridized. The next one is an alkene. So obviously these two carbon atoms have a double bond in between them. So because of that, both these carbon atoms are sp2 hybridized, whereas this is only having single bonds, so it is sp3 hybridized. Next, you have CH3 taken twice, CO. So the CO means it's a ketone and it has a double bond. So this particular carbon atom is sp2 hybridized, whereas this carbon and this carbon has only single bonds around them. So because of that, it is sp3 hybridized. So in this compound, actually it is CH3, I am sorry, it's supposed to be CH2, CHCN. So in this case, you have a double bond, right, between this and this carbon atom. So both these carbon atoms are sp2 hybridized, whereas CN has a triple bond in between the carbon and the nitrogen. Because of that, this carbon atom is sp hybridized. So this is sp2, sp2 and sp. Next is C6H6, that is benzene, and all the carbon atoms have a double bond, at least like one double bond between the other. So because of that, all these carbon atoms are sp2 hybridized. Next, we need to indicate the sigma and the pi bonds. So sigma bonds are basically single bonds. Pi bonds, on the other hand, are double and triple bonds. So in a double bond, you have one pi bond and one sigma bond. So in this case, you have one sigma and one pi, whereas triple bond will have two pi bonds and one sigma bond. So we need to figure out we need to indicate the sigma and the pi bonds. So C6H6. In case of C6H6, all the carbon and hydrogen bonds are sigma, and all the carbon-carbon bonds are also sigma only, whereas this, and this are pi bonds. So you have CC single bonds, so they are sigma bonds, whereas the double bonds are pi bonds. Next is C6H12. Now C6H12, we can show it in two ways. It can either be a cyclic structure or it can be a straight chain. If it is a straight chain, it will have one double bond. Okay, only then you'll have the valence. I mean, the number of hydrogen atoms, correct, right? So if there was no double bond over here, it would have been CH3 or CH3 here and CH2, and the number wouldn't have been 12 hydrogens. So this double bond makes sure that the number of hydrogen atoms is 12. So 12. So in this compound, all the bonds which are present are sigma bonds, except for this one, which is a pi bond. Whereas if it's a cyclic, all of them are sigma bonds only. Like you have CC single bonds, CH single bonds, all of these are sigma bonds only. Next is CH2Cl2. Now CH2Cl2, here you have all the bonds over here are all sigma bonds. You don't have double or triple, so they're all sigma bonds only. Next, CH2CCH2, which means here you have CH, this CH2 also. All of these are sigma bonds. Double bonds, on the other hand, one of them will be sigma, so CC sigma, CC sigma, whereas the other one, which is forming the double bond, will be the pi bond. So this and this are pi bonds. This is CH3. This was supposed to be H. I'm so sorry. So all these three are, all four of these are sigma bonds, whereas this would be a dative bond because oxygen has a minus charge. This, on the other hand, is one sigma and one pi. The last one, HCO and HCH3. All the single bonds over here are obviously sigma, the carbon and oxygen, this would be sigma and the other will be pi. So sigma bonds are single bonds, pi bonds. For a double bond, you have one sigma and one pi. For a triple bond, you have one sigma and two pi, like two pi bonds. Now we need to write the bond line formulas for isopropyl alcohol. So isopropyl is generally used for when the second carbon atom of the propane straight chain has a substituent attached to it. So because of that, at the second carbon, first we'll write the bond line for propane, and at the second carbon, you will have an OH group attached to it. Next is 2,3-dimethyl butanol. Now, generally for such structures, first thing you can do is draw the basic chain. So you start with drawing the basic number four. So it's easier to just draw the number of carbon atoms. So 1, 2, 3, and 4. Okay. And according to this, 2,3-dimethyl butanol. So at the second and the third position, we have methyl groups, and the first carbon atom is obviously having an Al, implies it's an aldehyde. So here it will be COH. Forgive me for my horrible drawing of the structure, but so this is the first carbon. So this will be first, this is the second, and this will be the third. So the third and the second carbon atom, you have a methyl group in each case. And so 2,3-dimethyl butanol. So it's better to start from the basic structure and then number it, and yeah, you can basically understand the position of, based on priority, aldehyde gets more priority than aldehyde gets more priority than methyl group. Next is heptane 4-one. Heptane 4-one, we can just draw the 7 carbon heptane. Hep means 7, so 7 carbon chain. At the fourth position, you have a double bond O because it's a ketone. So for these questions, you need to be very thorough with the concept of nomenclature. Next one, give the IUPAC names of the following compounds. First one is a benzene. You have benzene ring and it has a 1, 2, 3, 3-membered chain attached to it. So when you have a chain attached to the compound, then automatically the benzene ring becomes the substituent. Oh, I'm sorry. I'm so sorry. When you have a functional group, it becomes a substituent. But in this case, this particular chain does not have any does not have any functional groups or anything. It's just a carbon chain. So it's a 3-carbon chain. It's a propyl. So the name of the compound is propyl benzene. Next is this compound. First, it's always better to start with numbering the carbon chain. So first, the numbering would go from right. So this would be the first carbon. This is the second. This is the third and fourth. Oh, I'm so sorry. We need to include the cyanide group as well. So okay, where did that go? Okay. So this is the first carbon, 2, 3, 4, and 5, because cyanide group gets more priority over the methyl group. And you have a third position, you have a methyl group attached to this chain. So the name of the compound is 3-methyl pentane nitrile. The nitrile group is also part of the carbon attached to the nitrogen, is also part of the main chain. So this compound's name is the compound's name is 3-methyl pentane nitrile. Next is this particular compound. So 1, 2, 3, 4, 5, 6, 7. So if we go from right to left, the second, you have a substituent at the second position and the fifth position. Next, if we go from here, you have it at the third position and the third, fourth, fifth, sixth position. So based on the first point of difference rule, 2 is smaller than 3. So the name of this compound, and since it has 7 carbon atoms, it's a heptane. So the name of the compound becomes 2,5 dimethyl heptane. The next one, here we've been given this chain, and it's obvious that this particular carbon is closer. So 1, 2, 3, third carbon, 4, 5, 6, 7. So it's a 7-member chain. It's a hept. Third carbon has a chlorine and a bromine attached to it. So 3 bromo alphabetically. So 3 bromo, 3 chloro, heptane. The last but one, sorry. Here we have 2 functional groups. One is an aldehyde, one is a chloro. So obviously the aldehyde has more priority and it becomes the principal functional group of this particular compound, and it gets the number 1. So 1, 2, 3. So the third carbon atom, you have a chlorine attached to it. So 3 chloro, propan, Al, because it's an aldehyde. OL is an alcohol, Al is an aldehyde. Last one, you have 2 chlorine groups attached to this carbon, and you have an alcohol group attached to this carbon. So obviously alcohol will get more priority than the chlorine. So this carbon will be number 1, this one will be number 2. So 2, 2, because you have 2 chlorine groups attached to the same one. 2, 2, dichloro, ethan, all, because it's an alcohol. If you find it difficult to understand what we just discussed in terms of this particular question, there is basically a whole set of videos that I did just about nomenclature. We will continue with the questions in the next video.